Okay, so when we are moving from a single amino acid to a polypeptide chain, we need to form what's called a peptide bond. So here I have drawn an example of just a generic amino acid or two generic amino acids represented just by the R1, R2, just showing we have two different amino acids. We don't care about specifically which one right now. When we take these general amino acids, so we would take the first one, as you can see, I've drawn this one with the hydrogen already gone from the carboxylic acid in, and that's because we would be forming these peptide bonds within our bodies, and our bodies are already at physiological pH, which is around 7. So if we are looking back at our chart that we created, we would see that the pKa1s corresponding to the carboxylic acid end are all around the number 2. Therefore, if we are talking about our physiological pH or pH of 7, that hydrogen would already be gone. So we have no hydrogen here, but the oxygen is still present. Then on our second amino acid, in our generic amino acid for our polypeptide chain, we have 3 hydrogens on the N-terminus end, which is what we would also expect at physiological pH, since these hydrogens are removed, or one of them is removed at around a pH of 9. So we want to create a peptide bond. In order to do that, we have our monomers who want to come together to make a polymer. We have to remove water. So this would be a dehydration reaction. So we would take oxygen away from amino acid 1 and 2 hydrogens from amino acid 2. That creates our water, and that forms our polypeptide chain that we see here. What we actually formed was this bond right here, the peptide bond, which I highlighted in the orange. The beauty of this guy is that it has what's called partial double bond character. So if you were to draw the resonance structure of this, organic chemistry, then what we would do is we would draw it like this below. And you can see that the double bond that was here now moves between the carbon and the nitrogen. And what we know about single bonds versus double bonds is double bonds restrict rotation. We cannot twist something where we have what I did before in class. If I had a double bond, I cannot rotate these guys because they are restricted from rotation. But if I had just a single bond, I can rotate as much as I possibly want. So there is a restriction of rotation by any type of peptide bond in a polypeptide chain. So we have free rotation here, 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 and here, but no free rotation here. And that causes our polypeptide chain to have a little bit of rigidity.